start with our lesson today. From 5.2, we have seen some basic properties of logs. And of course, I do expect you to memorize this. Okay, it's quite easy to memorize, right? Okay. Now in this section, 5.3, we will learn 3 more rules and 1 change of base and apply that to examples. But you will see this 5.3 is more as a support for 5.4 that we will do later. Okay, first rule is product rule that says log base A of x times y equals to log base A of x plus log base A of y. You can say that log of product equals to sum of logs. Log of products equals to sum of logs. The second rule, quotient rule, log base A of x over y equals to log base A of x minus log base A of y. In other words, log of quotient equals to difference of logs. Power rule, log base A of x to power n for any n, including rational number, okay, equals to n times log base A of x. In other words, the exponent n here is brought to the front if the exponent n is the exponent of the argument. Now keep in mind that, note that we are not talking about this case, log base A of x to the n. Now this is not the same to log base A of x to the n. The exponent n in the first one is the exponent for the whole log, while the exponent n for the second one only for the argument, only for this x. Okay. Change of base for A and P both positive and both not equals to 1. Log base A of x is equal to log base P of x over log base P of A. Okay. Now, this is what I will do. I will prove the first and the third rule. Hopefully, using those proofs, then you can feel more about the nature of those properties. And then we'll do problems. Start with change of base. Okay. Proof. For the first one, proof product rule. By the way, there are actually a lot of different product rules in math. When you go to calculus later on, calculus for business, you will see product rule for the derivative. Okay, now, but the product rule that I talk about here is for logarithm. Actually, if you remember in algebra 1, the beginning algebra, we also have product rule for exponents. Now, proof product rule, log base A of x, y equals to log base A of x plus log base A of y. Now, hopefully by showing you the proof, not only you feel that better, you can also know what's the reason this is true. I will start with letting m to be log base A of x and m will be log base A of y. Now, then I change it into exponential form. Now, the exponential form will then be a to the m equals to x, a to the n equals to y. Now, think about this a little bit. Yeah, I change it from log form into exponential form. Now, therefore, the product of x times y will be a to the m times a to the n. Is right? But then by product rule from exponent, we learn product rule in exponent. When you multiply two factors with common base, like in this case, then you add the exponent. Right? Okay, now I change this back to log form. The log form for this would be log base a of xy equals to m plus n. But we know m, the way we defined it earlier at the beginning of the proof, m is log base a of x, the m is log base a of y. That's the end of the proof. Okay. Now, how about the proof for power rule? The proof for the quotient rule is actually quite similar. It's very, very similar. Now, it's basically you modify from here. You make it quotient, right? So you will get a to the m over a to the n, but by quotient rule, this is a to the m minus n, right? So log base a of x over y equals to m minus n, and then so on and so forth, right? Okay, that's for the quotient rule, the proof for the quotient rule. How about the power rule? Proof power rule. I don't have any intention, I don't think I will ever ask you to prove this, but I also know that learning proofs actually strengthen your foundation on how things actually works. That's why I show you the proof. Proof, the same, let m be log base a of x. So a to the m equals to x. Now take this to the power of n for any n. This is a to the n times n. That's the power rule from exponent. Now then, notice that this is the base, this is the solution, later on that will be the argument, and this is the exponent. So when I change it back into log form, this is log base a of x to the n equals to n times m, which gives us, if I substitute that m back, that will be n times log base a of x. That's the end of the proof. Okay, now that's the foundation. That's the problem. First, about change of base. We will need this change of base in 5.4. We just learned it a bit earlier. The purpose is the following. To compute log with any base using calculator. The thing is, most calculators only have log base 10 or natural log. So for example, suppose I want to compute what is log base 2 of 5. Now, and if you look at your calculator, you don't have base 2. You don't have base 2 in your calculator. No base 2 in most calculators. No base 2 log in most calculators. So how do we do this? Then we change the base. You can choose to use base 10 or base E. Actually, you can choose to use any base. You can use base 4 if you like. You can use base 8, base 9, base whatever, even base pi, base 2/3, fine. But the main purpose of change of base is to use calculator. So suppose I change it to base 10, it will be log base 10 of 5 over log base 10 of 2. So the argument stays with the argument at the top. The original base now becomes the argument at the bottom. And notice that the base for the logs at the top and the bottom, the base for the logs for the top and the bottom, the base here and the base here has to be the same. In this case, both of them base 10. Now, you can also use base E. So natural log of 5 over natural log of 2. Okay, either way, you will get the same result. Now, I will show you using my calculator, but please use your own calculator also. Please use your own calculator also to make sure you know how to compute using calculator. Okay, let me show you how to use our calculator. So I want to compute log base 2 of 5. Now, every time you are about to use your calculator, please rewrite that using change of base first. Rewrite it first. Okay, either one of these. Okay, now I will show you that either I use the first box, log 5 divided by log 2. So let's see. Log 5, close parenthesis, divided by log 2, close parenthesis. Okay, this is base 10, right? Enter. That gives me 2.32193. So this one here will give me 2.32193. Okay, now suppose I use natural log instead. It will be natural log of 5, close parenthesis, divided by natural log of 2, close parenthesis. Now the thing is, if you use base 10 on the top, you need to also use base 10 at the bottom. If you use base E on the top, then you also need to use base E at the bottom. Okay, now you see that we get exactly the same answer. Let me screenshot that calculator. Oops, sorry. Let me screenshot that calculator. Make sure you know how to use your calculator though. My assumption is you don't use TI-83 or TI-84. These are graphing calculators, so you're not supposed to use graphing calculator in this class. Okay, and round it to 5 decimal places. That's one. Second, when you compute this kind of log, do not compute it partially. Do not compute this way. Log 5, you compute that first, and then log 2, you compute that separately, and then you divide. What happened is, it is possible you have rounding error on the top and the bottom before you divide them. Okay, now if you do so, very likely you end up with too much rounding error, a compounded rounding error. Okay, so please don't do so. Just use calculator and hit it all at once. Okay. Now let's go back. That's one way, one thing about using your calculator. Let me see, I have a chat coming in. Yes, you will use TI-30X. You will use TI-30. Now, the thing is you need to learn how to use your TI-30, okay? You need to learn how to use your TI-30, either TI-30, TI-32X, TI-36, the calculators I recommend you to use at the beginning of the semester. Now, that's about change of base. Now, let me ask you to try, just to make sure you know how to do this. Let me ask you to try, for example, number 22. Log base 3 of 0.015. What will that be if you use your calculator? I will use my calculator also. But you need to try on your own. Make sure you know how to use it. Okay, can you tell me what you get? Anybody? Nobody say anything? Okay, I will write mine. This is what I get. That's right. But make it 5 decimal places, not 4. Okay, make it 5 decimal places. So that will be negative 3.82274. Okay, keep in mind, in my class, to give 5 decimal places for approximate solution. Okay. Now we will then go on to applying those properties. Let's see, for example, I tried to do some more examples, but at the same time, I don't think I can do all because of time. Okay, but let's see how to apply these formulas. For example, the properties. For example, I think we can do C number 24. Okay, the question is, use the properties of logs to rewrite and simplify the logarithmic expression. So we have log base 2 of 4 squared times 3 to the 4. How do we compute that? How do we compute this as much as possible? Notice that this is log base 2 of product, right? The product of two things, this guy and this guy, right? It's a product. If it is addition, you cannot split it. It has to be product or quotient. So this will be log base 2 of 4 squared plus log base 2 of 3 to the 4. Right? Using property number 1, product rule. And then using property number 3, I bring the exponent to the front, 2 log base 2 of 4 plus 4 log base 2 of 3. Okay, so I use rule number 1 and then rule number 3. Of course, in your test, you don't need to write this 1 or 3. I just give you a hint which property I actually use there. Now, the thing is, we can actually compute this one. We can compute this. What is log base 2 of 4? What is log base 2 of 4? That's 2, because log base 2 of 4. There are actually a couple of ways to look at that. Suppose we put the question mark here. So 2 to what power equals to 4, right? Okay, and you see, oh, it must be 2 squared, right? So that's equals to 2. That's how we find it. Okay, so this is 2 times 2 plus 4 log base 2 of 3. I think the furthest you can go is 4 plus 4 log base 2 of 3. Now we call this exact form, the exact solution. The exact solution. Now, if you want to compute that using calculator, then you go ahead, okay, using calculator. But here they just want us to simplify to the point that we get the exact solution. And the next thing after this is just simply calculator. Okay, let's go on further. Suppose, for example, I do number 30. Number 30. Yeah, we did this kind of question actually last week. Log base 5 of 1 over 1.5. They say do not use calculator. Yeah, call this x first then. Yeah, call that x first. So we will get 5 to the x equals to 1 over 125. Now, 125 is 5 to what power? Cube, right? Okay. But if you have 5 cubed on the denominator, you bring it up, it becomes 5 to the negative 3. By one-to-oneness, we get x equals to. So log base 5 of 1 over 125 is negative 3. Okay. Number 40. Maybe I jump to number 42 right away. Number 42, 2 natural log of e to the 6th minus natural log of e to the 5th. This is 2 times 6. How do you get that 6, Thomas? Basic property. In fact, I can name it. This is basic property number 3. Go back to basic property number 3. This one here. If the base here the same with this base, then the answer will be the exponent. Okay? Now, using the same idea, then the second term, this guy will be what? Be 5. Oh, that's Mickey Mouse, huh? That's 12 minus 5, that's 7. That's for number 42. Number 44. From here, then we will later on do the ones with variables instead of numbers. Log base 4 of 2 minus plus log base 4 of 32. There are two ways to do this. The first way is to compute each one of them. You see that, for example, log base 4 of 2 is log base 4 of 4 to the power of 1/2, right? So I kind of like rewrite that as base 2 in the argument. And the second term, log base 4 of 16 times 2, is it right? This guy becomes 1/2 plus, but log base 4 of 16 times 2, the 16 is 4 squared, the 2 is 4 to the power of 1/2. That's log base 4 of 4 to the power of 2 plus 1/2 is 5/2. So the second term simplifies to be 5/2. That's 6 over 2, which is 3. Okay, but that's method 1. That's the first one. I think the second one is a lot more interesting and more effective. The second method. Actually, you see that's log of the same base, right? And you add them. So I can say this is actually log base 4 of 2 times 32. So right, using property number 1. Instead of splitting them, I put them together. Why? It turns out that 2 times 32 is 64, which is base number of base 4. That's 4 to the power of 3. Okay? Now, let's do more. Let's do more. The following question, we need to rewrite them as expand as sum difference constant multiple of log. Constant multiple of logs. Suppose, for example, I do number 52. Number 52, natural log of cube root of t. That's natural log of t to the 1/3. And I bring that 1/3 to the front. That's for natural log of cube root of t. Number 54. Number 54, log without base, so that's base 10 of 4x squared y. Now this is log of product, right? Log of product. So this is log of product is sum of log. So this is log 4 plus log x squared plus log y. Are you with me so far? I'm not done yet. One more step. That's property number 1. And then I will apply property number 3 to the second term. So this will be log 4 plus 2 log x plus log y. Number 64. And I kind of like jumping around. I do the easy one first, and then later on I do a slightly harder one. But in between now and then, I teach you some basics such that we can skip a lot of steps later on. Okay, now number 64, log base 10. They write the base 10, but it's actually not necessary. Of xy to the 4th over z to the 5th. I will use property number 2 first. This is log of the numerator minus log of the denominator. That's property number 2. And then I apply property number 1 to the first term. That would be log x plus log y to the 4th minus log z to the fifth. Are you okay with this so far? One more step after this though. But are you okay with this so far? Okay, good. Now then the next step is I will bring the exponent of the argument to the front. The first term without exponent, so I just leave it like that. The second term, I will bring the 4 to the constant multiple of log. And the last term, I bring the 5 to the front or as constant multiple of the log. From the last example, number 64, let's summarize a couple things. Notice that if the argument is on the numerator, then the coefficient of that logs will be positive. In fact, the coefficient of the logs will be the exponent. Maybe I color it this way. You see that they are positive, right? Positive because it's on the numerator. In fact, the exponent that you see at the top, the exponent invisible 1 here and invisible 4 will be coefficient 1 for log x and coefficient positive 4 for log y. Now, the one on the denominator will have negative coefficient, this 5 here from the exponent of that z to the fifth at the bottom. Okay. In short, that the coefficient of that logs will be positive if it is on the top. It will be negative if it is on the denominator. Okay. Now, notice that it is actually quite consistent here. Notice that this 4x squared times y is all over 1, right? So it's on the numerator actually. That's why the coefficients are all positive. Okay, and we have plus 2 here because we have x squared there. Now, cube root is basically to the power of 1/3. Now notice that that 1/3 then moved to the front as the coefficient. Now, with that said, let's try if we can do this problem in one step. Number 56, natural log of x squared minus 1 over x cubed. Where x is greater than. This is just to make sure that the argument has to be positive, right? The argument has to be positive. At the hint side, we see that this will be a natural log of the numerator minus 3 times natural log of x. Is it okay so far? Almost done, but this is basically done from what we see in naked eyes. See, because this is the numerator, right? This is the denominator. In fact, because it's to the power of 3 at the bottom, then I have negative 3 as a coefficient. Now, the thing is x squared minus 1 is actually x plus y. I mean x plus 1, x minus 1, right? Okay, so I can actually break this. This is natural log of product. It becomes natural log of x plus 1 plus natural log of x minus 1 minus 3 natural log of x. Of course, you may prefer to do it this way first. You factor the numerator first, x plus 1 on the top times x minus 1, and at the bottom you have x cubed. Then you hit it right away. This is natural log of x plus 1 plus natural log of x minus 1 minus 3 natural log of. Now, with that said, can you tell me what will be number 58, which is natural log of 6 over square root of x squared plus 1. Now, let me give you 30 seconds to tell me the answer. Okay, what will that be? Am I too fast? Natural log of 6 minus, now you see that square root is at the bottom, that's why it's negative, and the exponent is 1/2 because of square root, right? Natural log of x squared plus 1. That's it. That's it. You tell me then, would you like to do it fast or do you want to do it slow? Either way. Yeah, but I offer you to do it fast. Number 60. Natural log of square root of x squared over y cubed. Now you can see this as natural log of x squared to the power of 1 over y cubed to the power of 1/2, right? That's the square root. This is natural log of x squared to the 1/2, that's x, y to the power of 3/2. So this is equal to natural log of x minus 3/2 natural log of y. So I simplify the arguments first before I play with the natural log. Now, alternatively, you can also do it this way. You can see this as natural log of y is x squared over y cubed to the power of 1/2. So I apply rule number 3 first. And then I apply rule number 2. Right? Okay. I play the movie a bit slow. So this is 1/2 times 2 natural log of x minus 3 natural log of y. Then distribute the 1/2. That gives me what I need. Okay, that's for number 60. Now, the reason I would like you to learn to do it fast because in the next page, on page 406, we actually try to condense that or put them together in single log. So basically rewrite in single log. Rewrite in single log. So if you can do it fast, it will be much better, right? Okay, let's say, for example, we have question number 76. Number 76. We have 2 natural log of 8 minus or plus 5 natural log of z minus 4. If I play it slowly, I hope you can be patient. Okay, if I play that slowly, this is I bring the 2 to the exponent of the argument, and I bring the 5 to the exponent of the argument here, right? And then sum of logs equals to log of products. Now the thing is, do you think you can do this in one single step? Which I hope you can try doing. Okay? Now, let me ask you to try number 80. You do it. Number 80. And then number 82. Number 80, let me write down the question. This is 4 times, in case you don't have your textbook handy right now, 4 times bracket ln c plus natural log of c plus 5 minus 2 natural log of c minus 5. Okay, condense that into a single log. Rewrite that into a single log. Number 82, 2 bracket 3 natural log of x minus natural log of x plus 1 minus natural log of x minus 1. Okay. And finally, as an extra, let me ask you to compute log base log base 5 of 125 cube root of 25. What is that? Without using calculator. Now let me give you 1, 2, 3, 4, 5, 6 minutes from now. So we come back at 12:03. Number 80, this is, I do it a bit slower, okay? But if you do it fast, you will get the answer to be natural log of c to the 4th z plus 5 to the 4th over z minus 5 squared at the bottom. Okay, now this is 4 natural log of c times c plus 5 minus 2 natural log of c minus 5. So this is natural log of c plus 5 to the 4th minus natural log of c minus 5 squared. Okay. This guy here, this is 2 times natural log of x cubed on the top over x plus 1 at the bottom, x minus 1 at the bottom. If I square it, then if I bring the 2 to the argument, I will get natural log of x to the 6, x cubed squared, right? X to the 6 over, I will get x squared minus 1 being squared. Okay, because this guy here is x squared minus 1. Okay, now the 2 will go to this part of that there, part of that here. That's one number 82. Now the extra problem. How do we answer that question? Log base 5 of 125 cube root of 25. If I need to solve that problem, you have a couple ways to do this. Okay, you have a couple ways to do this. The first way, I separate them first. Log base 5 of 125 plus 1/3 log base 5 of 25, right? Okay, but 125 is 5 cubed, so this is 3. 25 is 5 squared, so this is 2. This will be 3 and 2/3. Okay, now that's for 5.3. Now we go on to 5.4. Yeah, I go on to 5.4. The first part, I don't think I can finish it in one day. This section, 5.4, consists of 2 parts. 5.4 is solving exponential and logarithmic equation. Solving exponential that's part A, and logarithmic equation. Now, with the time we have left today, I will do the exponential part. Logarithmic equation requires you to be strong in your logarithmic property. So that's why I leave it to Thursday. Okay, so 5.48 idea. To solve exponential equation, if I can rewrite a to the x equals to a to the y, then by one-to-oneness of exponential functions, x equals to y. Now, on the other hand, suppose a to the x equals to something which is not base a, let's call that b, then I will change this into log form, log base a of b equals to x. Now, then maybe you use calculator. Then from there you use calculator. Of course, you do change of base first. Change of base first, right? Either you use log base 10 or log base e, and then you use calculator. Okay. Now, if the number can be changed into base a, you have to change it to base a. For example, I go to the question right away. Number 14. And you will see I tend to do it quite fast here. 3 to the x equals to 343. I mean 243. Now you need to recognize 243 as 3 to some power. So 3 squared is 9. 3 cubed is 27. 3 to the 4th is 81. And 243 is 81 times 3. Okay, so you rewrite the right-hand side as 3 to the 5th. So x equals to 5. Now, that's what I meant by if you can rewrite the constant as the common base, then you have to. Okay, so yes, part of that you need to memorize. Number 16. 1/4 to the x equals to 64. Now, the left-hand side, 1/4 is 4 to the negative 1. So I basically rewrite it in base 4, and the right-hand side, that's 4 cubed. So 4 to the negative x equals to 4 cubed. Negative x equals to 3, x equals to negative 3. That's for number 16. Number 20. E to the x equals to 4. Now 4 cannot be written in base e. So then I need to use log. This is base e. So natural log of 4 equals to x. Then you use your calculator. I use my calculator. Natural log of 4 is x equals to, so this is what we call exact solution. The approximate solution will be 1.38629 decimal places. This is what we call approximate solution. Number 22. I do a lot of problems, so that you have something to study at home to do harder problems. Log x equals to negative 2. What is the base? That's base 10, right? Now to solve for x, then I change it into exponential form. That's 10 to the negative 2, which is 1 over 10 squared, which is 1 over 100. or in decimal, that will be 0.01. Number 24, let me do it here. Log base 5 of x equals to 1/2. Base 5, right? So change it into exponential form. X equals to 5 to the 1/2, or simply square root of 5. That's the exact form. Then you use your calculator, square root of 5, to give us the approximate form, the approximate solution. And again, the approximate solution should be up to 5 decimal places. Now, these are the basics. These are the basics. Going on. Number 32. E to the negative x squared equals to e to the x squared minus 2x. Now, you have common base already. The base are the same. Left and right are the same. Then the exponent must be the same. Negative x squared equals to x squared minus 2x. Set one side equals 0. And, I need to solve by factoring, huh? So that's 2x factor out, x minus 1. So either x equals to 0 or x equals to 1. I think that part is quite easy. Number 36. For e to the x equals to 91. What is your first step? Divide by 4. E to the x equals to 91 over 4. Right? And then that's definitely not base e. So I use natural log of the argument 91 over 4 equals to x. Okay, that's the exact solution. Of course, you can also write it as natural log of 91 minus natural log of 4. Yeah, both of these are exact solution. Now, then you use your calculator to get the approximate solution. Now, our textbook wants you to do it in 3 decimal places. I want you to give me 5 decimal places. I get x equals to 3.12457. That's the approximate solution. Now, with that said, let me ask you to try number 40. Can you try number 40? Six to the power of 5x equals to 3000. Now, I need you to give me the exact and then approximate solution in 1, 2, 3 minutes. So I apply log base 6. Log base 6 of 3000 equals to 5x. Now then divide by 5. X equals to 1/5 of log base 6 of 3000. Now that is my exact form. Now the thing is, how do we compute that using calculator? So I rewrite that first into, let me make it natural log. So natural log of 3000 over natural log of 6. I do change of base, right? This is still exact, by the way. This is still exact. Okay, so x is equal to natural log of 3000 over 5 natural log of 6. That is still exact. But then the next thing is calculator. Okay, so that's natural log of 3000 natural log of 3000 divided by parentheses 5 times natural log of 6. I get 0.89369, which I think this is not really right. Oh yeah, that's right. Yeah, that's okay. That's right. This is the approximate. Okay, let's go on to the next page. Page 416. I would like you to tell me, pick 3 questions to do. On page 416, pick 3 questions to do. 3 problems that you want me to do. Okay, I give you 1 minute to choose. I wonder how many of you have your textbook handy when you take my class, when you are in my class. Okay, I do number 58 first. If you make no choice, I do number 58 first. Number 58, 8 times 4 to the 6 minus 2x plus 13 equals to 41. Now you will see the idea is to isolate the exponential part. So I will isolate this yellow one here. Okay, subtract by 13. That's 28, right? And then divide it by 8. 28 divided by 8. That's 7.5. Reduced by 4. Reduced by 4. 7.5. Okay, now then apply natural law. What can I do with this? Then apply natural log. No, actually log base 4. Log base 4 of 7.5, which is 3.5, is equals to 6 minus 2x. Okay, so 2x, let me move the equal sign here now. So 2x equals to 6 minus log base 4 of 3.5. Then divide by 2. Okay, that's the exact form. Do change of base so that you can use calculator. 3 minus log 3.5 over 2 times log 4. Then when you punch your calculator, learn to punch it right. I get x equals to 2.54816. This is the approximate solution. So the idea is actually simple. You need to isolate the exponential part. Okay, and then change it into log form. Of course, another challenge is when you use calculator, right? From that exact form, how to do the change of base so that you can use calculator. Number 60, number 64, number 62. E to the 2x plus 9e to the x plus 36 equals to 0. I think I chose a wrong question here. Not a good question. Let me do number 60 first, and then I do 62. Do number 60 first. Number 60, this is minus 5x, and then plus 6. Okay, now I want you to realize that we can rewrite the first term actually as e to the x being squared. Now, so you now get a quadratic-like equation. Let u equals to e to the x such that you get u squared minus 5u plus 6 equals 0. It's u minus 2, u minus 3 equals 0. So u equals to 2, u equals to 3. Now I change it back, so e to the x equals to 2, e to the x equals to 3. So natural log of 2 equals to x. That's the exact form, right? And then you use the calculator to find the approximate form. Now, why I want to do number 60 first? Because I want to show you that this the first term in this question here is the square of the second term. The square of -5 of the second term. Okay. Okay. Now, number 62, however, give me no solution for the following reason. E to the 2x plus 9e to the x plus 36 equals to 0. Solution, I let u, the substitution, to be e to the x, right? Okay, so then my equation becomes u squared plus 9u plus 36 equals 0. Now, I don't think this is factorable. Yeah, I don't think this is factorable. I don't even want to do completing the square. So let me do the discriminant first then. Okay, so the discriminant will be b squared minus 4ac. That's 81 minus 144. That's negative 63, which is less than 0, which implies no real solutions. Okay. In other words, if I really insist to go, then my u12 will be negative b plus minus square root of negative 63 over 2a. That's negative 9 plus minus, that's 9 times 7, 3 I square root of 7 over 2. But that's e to the x, right? Okay, so x will be natural log of negative 9 plus minus 3I square root of 7 over 2. So you have two solutions there, x1 and x2. But none of these are real numbers. None of these are real numbers. That's the problem. Okay? None of these are real numbers. So your textbook will say no solution. Yeah, but I just show you what happened if it's not factorable. What if it is not factorable? Don't forget you still can use completing the square, or in this case I use quadratic formula, right? Second, what if the discriminant is negative? Well, if the discriminant is negative, like in this case, there are no real solutions. But what if it is positive? Then you have real solutions. Okay, then you have real solutions. Okay, let's do maybe one more question, as hard as possible. But which one's good? Number 64? Number 64 is actually on the easy side. 400 over 1 plus e to the negative x equals to 350. Remember, I need to isolate the exponential part. So my main goal is to have this by itself on one side. And to do so, I will multiply both sides by the LCD. That's a common practice if you have a fractional equation. Okay. And then I think I will divide by 350 and subtract by 1. Let me divide by 350 first, and then subtract by 1. That gives me e to the negative x. Okay, okay, so that's 8 over 7 minus 1 equals e to the negative x. Oh, by the way, 8 over 7 minus 1 is what? 1 over 7. Right, so natural log of 1 over 7 is negative x. But natural log of 1 over 7 is negative natural log of 7. Do you know why? Because 1 over 7 is 7 to the power of negative 1. Right? So you rewrite that 1 over 7 to 7 to the power of negative 1, and then you take the power of negative 1 here. Okay? That's the exact solution, and of course you can use calculator to find the approximate solution. I think I will stop here. Your suggested homework from this section will be 5.4, part A, number 13 to number 23, and then number 29 to number 69. Just do every other odd. I think it's good enough. Yeah, but please do that though. Okay, please do that. Now you know that I have office hour before class, right? Before our class. Okay. So if you have any question, please let me know. It will be nice if you can send me an email first, Thomas, how to do this problem, in case I can answer it earlier, right? But yeah, feel free to ask me a question. I didn't give you suggested homework here. Huh? Okay, so for 5.3, suggested homework will be from number 15 to number 83. 15 to 83. It's every other odd. Okay, that's for today then.